Hey everybody, it's Wojo. Today we're going to be talking about inequalities and more important, kind of how to graph them or how to identify a graph. We're going to focus on open circles versus closed circles when we're talking about graphing inequalities on a number line. You're going to have an assignment that looks something like this, and so we're just going to talk really quickly about how you would do that and then let you guys try it. So let's go ahead and move over to the dot camera. I got a couple things to show you. So if we take a look at just the symbols, I just want to remind you that these are the four symbols we use for inequality. The less than symbol points to the left if you think about it as an arrow, left for less than. If it's got the less than symbol with a little line underneath it, that means it could be less than or equal to. So less than would be something like 1 is less than 2. We could also say 1 is less than or equal to 2. That would also be true. It's not equal to 2, but it is less than. We could also even say something like 2 is less than or equal to 2. Even though 2 isn't less than, that's where this word or comes in. So it's less than or equal to. We use less thans or equal tos quite a bit. When you say you can spend up to $5, that means you can spend anything under 5 or exactly 5. So we do have a reason that we have less than or equal tos. Greater than symbol is the same except for it points to the right, so if you think of it as an arrow, and then the greater than or equal also has the line underneath it. So if it has the little line underneath it, that means it could also be equal to. What we're going to look at today is the graphs of these. And so you might see something that says graph all the solutions represented by the statement the numbers I'm thinking of, x, have to be greater than 3. And so if you just think about it, numbers greater than 3 would be 4, 5, 6. You could even have decimals like 3.1, 3.2, 3.3. So if I wanted to graph those, I could say, well, 5 is greater. I could say 4 is greater. I could say 4.5 is greater. But instead of putting all the different dots on the number line, instead we have a way that we graph it that uses open versus closed circles, and then we just kind of draw the line over top of it. And so here, if it says x can be greater than 3, we don't want to include 3 in the answer because it can't be 3. It would have to have the equal sign to be 3. So what we would do is we put an open circle at 3. So notice I'm not filling in that circle. And we would say I want all the numbers greater than 3. And so then we would just draw an arrow or highlight all the numbers on the number line to the right of 3. And so we would just kind of draw this arrow and say any number that's in this spot here is going to make that, or is going to be a solution for it. So all of these numbers are not a solution. They're not greater than 3. But starting at 3, but not including it. We're not going to include 3. That's why we have an open circle. It's going to be this way. And so we have just a nice easy way of showing this. The less thans and greater thans, we do what we call an open circle. So we don't fill it in. And then less than or equal and greater than or equal to, when we go to graph it, we'll use a closed circle. So we will fill it in. And so I think that's the part that'll be a little confusing. So I just want to talk about it just for a second. You know, if I had x is greater than 3, and then I asked you, well, graph x is greater than or equal to 3, how would those graphs differ? In this one, I don't want to include 3 as an answer, but in this one I would. And so the difference is when you go to graph these, if this is 0, this is 1, this is 2, 3, 4, 5, instead of saying an open circle at 3, we would close in that circle. When you close in a circle in algebra, what you're telling the reader is 3 is part of the answer. Here 3 isn't. I still want all the numbers that are either equal to or greater than. So I still want to fill in or shade in all the numbers to the right as well. And so instead of shading it all in, what we do is we just kind of shade it in and then draw an arrow to say any number this way of 3 would work. The difference between these two is if it's just greater than, we use an open circle at the boundary point. If it's greater than or equal to, we close it in. And so when you look at this, look at the difference. When it has the equal sign, like these two do, we use a closed circle at the boundary number. When it has when it has no equal sign, we say open circle, which means that boundary is not part of the solution. If you get that, the open versus closed circle, the assignment today in Delta Math shouldn't be too bad. So let's do a couple together so you can see kind of how it works in the assignment, and then it's all you. All right, so we're back at the assignment. It just says 1-point inequalities. There is a help video. If mine didn't work, you can always try their help video. And it's going to give us 100 seconds to try to get 10 of these right. And so when we hit start, notice our timer starts, but don't worry, you got lots of time. And it says which inequality is represented on the line. So there's two things I look at. You notice these answers, they use all four of the symbols: less than, greater than or equal, or less than or equal. And so the first thing I notice is this is an open circle. So I got to remember that an open circle means it's one of these two. It does not have the equal sign. See how this one has the equal sign, this one has the equal sign? If this was a closed circle, it would be one of these ones. So now that I know what's between the less than or the greater than, I just have to think about, well, what is this representing? It says all my answers are either less than -3 or greater than. Well, this -4, 5, 6, 7, 8, 9, 10, those are all less than -3. Also, I can kind of follow the arrow. It's pointing to the left, so I want all the answers left of -3. Click it. It lets me move on. This one, it wants me to also have a less than or greater than. It's pointing to the left, so I want all the less than. I want all the numbers less than 7, so I just find the one that has less than. This one's also, so I'm just going to keep going. Now notice it changed here. This is a closed circle. So the closed circle isn't going to be, it's still going to be less than because it's to the numbers to the left. It's all the numbers smaller. But it also can be -6. So because it's closed, we're going to have the equal sign of -6. Now if you do get one wrong, I just want you to realize that it's going to kind of tell you what you did wrong on it, and then it'll let you start over. And you're just going to be able to keep going. And we do want you to do this enough times that you just look at this and go, oh, that's greater than -9. Oh, that's less than or equal because it's closed circle. That's less than 10. It's to the left. And we want you to have enough repetition. Getting 10 right in 100 seconds, that would probably show us that you have a pretty good idea of how to do this. This one's all the numbers greater than -10 because the line is pointing to the right. It's an open circle. And so it's going to have to be just greater than. Closed circle, so it's going to be less than or equal to. Open circle, so just less than. Closed circle, so less than or equal. It's pointing to the left. And you'll be able to go through and hopefully you get them. And just don't mess up on the last one because that would be tragic. It'll let you keep going if you want, but once you get your 10, you're good to go, and it'll just keep going from there. Also, there's one other Delta Math video. Just make sure that you remember the less than or greater than. So just ask you some true-false questions. Just make sure you remember less thans, point to the left. And so you just want it to read true. Is 3 really less than 4? Things like that. So hopefully this made sense. If you guys have questions, just email me. I'll talk to you guys later.